This video begins our unit on sequences and series, and the first thing we'll talk about are sequences today. We'll be doing some new work with sequences, but we'll still need to go back to our old basics, working with fractions, being able to substitute, solving simple equations. We'll first talk about the difference between a finite sequence and an infinite sequence. The sequence of numbers here is actually what you're seeing on this line in green. The sequence is the 2, 4, 8, 16, 32, and 64. This has a limited number of terms in it. There are only 6 terms in the sequence, so we call that finite. This one, however, by showing the 3 ellipses at the end, the comma, and then the 3 dots there, that is an infinite sequence. It means it continues forever. What you see with the n equals, the n is just counting the position of the number. So we're looking at position 1, position 2, position 3, position 4, and we use n as a little subscript. We'll refer to every number in the sequence as an a sub n. So this would be a sub 1. This number here would be a sub 3. This number here would be a sub 6. So that n is just going to be the subscript on those a's. An infinite sequence is really just a function. Instead of seeing x's and y's, though, you're going to see things like n's for the x values and a sub n's for the y values. Your domain will be all of the n's, and we'll always start with the first position, so n will always start off as a 1. The range is going to be all of the answers or all the terms that you come up with, the a sub n. So let's see what this looks like in practice. We have something called an explicit formula. An explicit formula tells us exactly how we could write any single term in the sequence. So I'll start with an n of 1. The first term in the sequence means I'd be plugging in a 1 into this formula. That would give me 3 times 1 minus 1, so my answer here is 2. For n equals 2. For the second position in the sequence, I would be plugging in a 2 here. 6 minus 1 is 5. For position 3, I'd be plugging in a 3 right there. Minus 1 gives me 8. So you can see the pattern that's going on here. When you substitute like that, you can clearly see the pattern. So my sequence here would be the terms 2, comma 5, comma 8, and we could keep going forever with that. On the other side of the screen, another explicit formula tells me exactly how to calculate each position, each term in the sequence. Everything under the a sub n is a term in the sequence. So starting off with n equal to 1, we'll do the first 3 terms here. We'll do the first term, the second term, and the third term. I'm going to do this by substitution. We have some fraction work here. We're substituting a 1 for n, so it's 2 times 1 plus 1 over 1 cubed. That's going to give me 3 over 1, which is 3. For n being equal to 2, it's going to be 2 times 2 plus 1 over 2 cubed, which is 415 over 8. For the third term, it's going to be 2 times 3 plus 1 over 3 cubed. So we've got 6 plus 1 is 7 over 27, sorry. And so that's how an explicit formula works. It says you can calculate a sub n, where n is any number in any position in the sequence, just by plugging in an n on the opposite side. We have something else called recursive formulas. When you see a recursive formula, you're going to see 2 adjacent terms. An n and an n plus 1 would be adjacent terms in the sequence right next to each other. A lot of times in recursive formulas, you'll also see a sub n and a sub n minus 1. This would come first, this would come second. So it's any 2 adjacent terms, you'll see the recursive formula. So we can use the recursive formula to write the first 4 terms. First 4 terms would give us an n of 1, an n of 2, an n of 3, an n of 4. And this information is telling us what a sub 1 is. So I can go over to here and say this is minus 2. If I know what the a sub 1 is, then that will allow me to calculate a sub 2. And so I take a sub 1 and I square it. A sub 1 was a minus 2. I'm going to square that. I'm going to add 3. It's going to give me 4 plus 3 is 7. I move on to a sub 3. Well, if I want a sub 3, that means I can take a sub 2, which was a 7, and I'll square it, and I'll add 3. And that's going to give me a 49, 3 is 52. And a sub 4, got some intense math coming up here. A sub 4, I'm going to find a sub 4 by taking a sub 3 and squaring it. A sub 3 was 52. I've got to square that number and then add 3 to it, and I'll leave that up to you in your calculator. Over here, another recursive formula. Again, I'm given the first position in the sequence, a sub 1, and I'm told that number is equal to 16. And from there, I can move on and calculate other terms. Now notice here that this is the term before the one I have. So I have term 1, that means n is 2 right now. So a sub 2 minus 1, this would be a sub 1. I'm going to be putting a 16 into that position in the formula. So I'm at a sub 2, and that equals 1/2 of a sub 2 minus 1, or a sub 1, 16. Let's move on to the third term in the sequence. I'm now at a sub 3. I'm going to calculate that by taking 1/2 from the formula, again it's a constant, and using my a sub 2 term. N is now 3, and so 3 minus 1 is 2, so I'm going to use that term I got of 8. So 1/2 of 8 is now equal to 4. We'll do one more term here. The last term is the fourth term. That means n is now 4. That means 4 minus 1. This position is now a sub 3, so we'll take 1/2 of whatever we got for a sub 3, and that number was 4. And so my answer there is 2. Just recursive formulas. At this point, we're going to move on to a special class of sequences called arithmetic sequences. And it is simple arithmetic. When you think about the word arithmetic, it will be simple arithmetic in being able to calculate these, but there's going to be a couple of things you're going to have to memorize. First of all, an arithmetic sequence will have a constant difference. And we say difference, it doesn't have to be negative. It can be a positive or a negative number. We're going to call that constant difference D. And that D is going to be what happens when we move from the first term to the second term, or we move from the second term to the third term. And since it's constant, it never changes. So let's just analyze this series of numbers here. First of all, this is a sub 1. This position would be a sub 4. So n here is 1, n is 2, n is 3, n is 4, etc. To get from 3 to 7, I can add 4. To get from 7 to 11, I add 4. To get from 11 to 15, I add 4. So my constant difference here is a positive 4. And I like to write the pluses or minuses. It helps me to just keep track of what I'm doing mentally, because you could also have a constant difference that's negative. And then in that case, the numbers will be going down. This one, 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8, etc. So my constant difference for this one would be a plus 2. So there we're finding the value of D for the common difference. Once we found that value, it allows us to, well, we could just keep going. And it would be very easy to just keep adding 2 in the second row. It'd be very easy to just keep adding 4 in the first row. And that seems easy until I ask you to tell me what the 150th term in the sequence would be, and then we want to have some shortcut ways of doing this. So we have a formula we need to memorize. This formula right here is going to allow you to come up with an explicit formula, just like the ones I gave you on the first screen. I gave you those formulas and we just plugged in and we got our answers. In this case, we're going to use this version of the formula here anytime we have an arithmetic sequence. Notice that there's a D in it, and there's actually a multiplication in between that n minus 1 and the D, and that's not really a proper way to write it, so we're not going to leave it that way. Once we plug in, we're definitely going to have to clean that up and come up with a simplified version. So we'll memorize this formula here. This says that any position is equal to the first position in the sequence, whatever a sub 1 is, the very first number, plus, if it's arithmetic, we're adding, think of it that way, n minus 1, there's the idea of the term before the one you want, and then we're going to multiply by D, our common difference. So A is always the very first number in the sequence. D is that fixed or constant difference that we found on the last screen. We'll plug everything in and then we'll clean up that formula. We always want a simplified version of it. If you look at this is a simplified version of it, but in the simplified version, whatever your coefficient is for that n term, that's going to be your common difference. If you take a look at this, I'll call it backwards distribute, if you backwards distribute that D, you're going to have that common difference term sitting in front of n. So the common difference for this formula would be a 6. Let's practice working with this. We want We have an arithmetic sequence. The first three terms are minus 12, minus 6, and 0. We want to find the 25th term. Well, how do we get from minus 12 to minus 6? We add 6. And how do we get from minus 6 to 0? We add 6. This means that a common difference is equal to plus 6. And right here we have another very important piece of information. This is actually a sub 1. First term in the series. If I have D and I have a sub 1, I can use this formula to come up with an explicit formula. So let's do that. A sub n will be equal to, I know what a sub 1 is, I'm going to plug in a negative 12 there. I'm going to bring down the plus. I'm going to bring down the n minus 1, and I know what D is. It's a plus 6, so I'm going to multiply by 6 at the end. And now we'll just clean up. We're reverse distributing that 6. It's going to give me negative 12 plus 6n minus 6, which is going to give me a negative 18 plus 6n. Really, we want to write it with the n term first, just like if we were doing a y equals mx plus b. So we'll say a to the n is equal to 6n minus 18. So that is my explicit formula in simplified form, and now I can use that to find a sub 25. A sub 25 means n is 25 equals 6 times 25 minus 18, which is going to be 150 minus 18. You don't need to show the arithmetic. Once you have all arithmetic here, you're free to pick up the calculator. So we end up with 132. So the 25th term of the sequence would be 132. One more, I'm practicing with this explicit formula here. Given a sub 1 is 3x, d equals minus x, find a sub 7. Got a little algebra going on here. A sub n will be equal to, in place of a sub 1, I'm going to write 3x. I'm going to continue my formula plus n minus 1, and my d is a negative x. I'm going to write that in red because it's actually a substitution. But it's not minus x, we're multiplying by that negative x on the end. That's a multiplication in there. So now when we reverse distribute, minus x times n is minus xn. Minus x times minus 1 is plus x. And we'll clean this all up. We'll combine what we can. We can combine the 3x and the x will give me 4x minus xn. And we have to find a sub 7. Finding a sub 7 is going to be in terms of x because we can't get rid of those x's. So a sub 7 is going to be equal to 4x minus, and that was an x times n in there. So that's going to be a sub 7 means n is 7. 7x, 4x minus 7x gives me a minus 3x. So that one involves a little bit of algebra because we took all the numbers out of it. And I'll leave that one for you to give it a try on the video if you want to watch the video and do that one. We're going to take a look at the recursive formula. We've got an explicit formula, we've got a recursive formula. There's no cleanup involved in the recursive formula because it's pretty darn simple when you see it. This says that the term, the fifth term, is the fourth term plus your common difference, which should make a lot of sense. You can memorize it if you want to, but you ought to be able to come up with that. And it's always in terms of, we're using n minus 1 here. We use that recursive formula. So I take the 14th term. It will look like this. If I have the 13th term, I can add whatever my common difference was to the 13th term, and I'll get the 14th term. So a sub n is the current term, a sub n minus 1 is my previous term, and d is the constant difference plus or minus. No cleaning up on that one should you have to come up with it. Okay, we've got an a sub 1 is 28, a d is 10. Find the first three terms in the explicit formula. But I'm going to change the instructions here slightly. I'm actually going to have you find the recursive formula. Well, in order to find the recursive formula, a sub n is equal to a sub n minus 1 plus d. I'll need to know what d is, and I have d already, but all I have is a sub 1. So in this case, I'm going to start listing out the terms. If I know a sub 1 is 28, then I know a sub 2 is 38. I know a sub 3 is 48, and now that might help you see in terms of the n and the n minus 1. Here, n is equal to 3, and so if I want to know what the third term is, I would be taking the second term and adding d to it. So I can find any term by taking the term previous and adding 10. And that's a little bit less less useful than the first one, I think, because the explicit formula allows us to find any term fast. If I presented you with just this and I said, well, find the 150th term, that'd be great if you knew what the 149th term was. But you're not going to know that unless you know what the 148th term is, etc., etc. So we tend to use that explicit formula more to find things. Okay, a few things. Please, when you start your homework sheet, write down some of these things that you have on the right-hand side of the screen here so that you're not doing more than you need to.